Okay, one problem like this. If sigma p is equal to 1 to n, sigma m is equal to p to n, ncm into mcp is equal to 665. We have to find the value of n here. So, in the first step, we have to expand these two, both of these, by applying NCR formula. NCM, that means we can write it as n factorial by m factorial into n minus m factorial. Okay, we have to apply NCR formula for both of these. So NCM means n factorial by m factorial into n minus m factorial, and for MCP it is m factorial by p factorial into m minus p factorial. Okay, so cancel the like terms. M factorial get cancelled. Now the remaining can be expressed as like this: n factorial by p factorial and 1 by n minus m factorial into m minus p factorial. Okay, so if n minus p factorial is here, then we can write it as NCP. So for that purpose, we have to multiply the nr and dr with n minus p factorial. So let us see that n factorial by p factorial into n minus p factorial. Okay, if n minus p factorial is there, then it is nothing but NCP. So for that, we have to multiply numerator and denominator with n minus p factorial. So here also n minus p factorial by n minus m factorial into m minus p factorial. Okay, so which is equal to 665. And this one can be expressed as NCP. We know that NCP means n factorial by p factorial into n minus p factorial. Similarly, here the second one can be expressed as like this: n minus p factorial, n minus p c m minus p. If we expand this, we get like this. Okay, n minus p c m minus p, which is equal to n minus p factorial by n minus m factorial into m minus p factorial, and this is equal to 665. Okay, so this is all equal to n minus p c m minus p. So applying NCR formula, we get this. Okay, so the sigma, write the sigma p is equal to 1 to n, sigma m is equal to p to n. Okay, next continuation. Okay, continuation. Now we have to rearrange the terms like this: sigma p is equal to 1 to n NCP, and the second term is like this: sigma m is equal to p to n n minus p c m minus p, which is equal to 665. Okay, now we have to expand this second series. Sigma p is equal to 1 to n, p is equal to 1 to n NCP. Here we have to substitute the values from m is equal to p to n. Okay, so here p is equal to 1 to n means it is increasing. Okay, so similarly m is equal to p to n means it is also increasing sequence. So if we substitute m is equal to p, then we get n minus p c 0. If m is equal to p, then p minus p, that means 0. Next we have to substitute p plus 1 because it is increasing. P is equal to 1 to n and m is equal to p to n. 1 to n means 1, 2, 3 and so on like that. Okay, So similarly, P to N means P plus 1, P plus 2 like that, okay. So it is increasing sequence. So N minus P, C0. Next we have substitute P plus 1 here, N minus P, P plus 1 minus P. So P cancel, we get 1. Similarly, in this way we get N minus P, C2 and so on. At last, finally we have to substitute M is equal to N, okay. N minus P. So M is equal to N means N minus P. N minus P, C N minus P, okay, like this, which is equal to 665, okay. So that implies sigma P is equal to 1 to N, NCP, and by observing this expansion, it is nothing but it is in the form C0, NC0 plus NC1 plus NC2 and so on, NCN. So the formula is 2 power n, okay. NC0 plus NC1 plus NC2 and so on, NCN. That means sum of all binomial coefficients, which is equal to 2 power n. Here, so n minus p is there in place of n. By comparing these two expansions, n minus p is in place of n, okay. So this can be expressed as like this, so 2 power n minus p, okay. Here instead of n minus p is there, okay. That is only the difference. So we can write it as 2 power n minus p, okay. Here n minus p is the prefix, here n is the prefix. Okay, continuation. Okay, continuation. So once again we have to apply the values for p is equal to 1 to n. So for p is equal to 1, it is equal to nc1 into 2 power n minus 1. For p is equal to 2, p is equal to 1 to n means these are increasing, okay. So nc2 2 power n minus 2. Next, if p is equal to 3, then we get nc3 2 power n minus 3 like this. If p is equal to n, then we get ncn into 2 power n minus n, 2 power n minus n, that means 0, okay. So this is equal to 665. So by observing this expansion, here nc0, so one term is missing, we know that it is nc0 into 2 power n, okay. So adding and subtracting, subtracting nc0 2 power n, okay, on LHS. So we get like this, nc0 2 power n, next nc1 2 power n minus 1, next nc2 2 power n minus 2 plus and so on, ncn 2 power n minus 1, that means 0, minus nc0 2 power n, which is equal to 665, okay. Here nc0 2 power n is not there, so we have to add and subtract nc0 2 power n, okay. Next, continuation. Okay, continuation. From nc0 2 power n to ncn 2 power 0. So what is the binomial required here? So let us see this formula. X plus 1 whole power n, that means nc0 x power n, nc1 x power n minus 1, nc2 x power n minus 2 like that, and the last term is ncn x power n minus n means x power 0. So Comparing these two expansions, we have to write the binomial for this expansion is 2 plus 1 whole power n, okay, minus NC0 means we know that it is equal to 1. 1 into 2 power n, so 2 power n is equal to 665, okay. From NC0 2 power n to NCn 2 power 0. So this is all equal to 2 plus 1 whole power n by comparing these two, okay. So this is equal to 3 power n minus 2 power n, which is equal to 665, okay. So what is the value of n? For what value of n this is equal to 665, okay. So since this is 665, suppose if we take n is equal to 6, what we get? 3 power 6 minus 2 power 6. So 3 power 6 means 729, we know that. 2 power 6 means 64, okay. So taking subtraction, 9 minus 4, 5, 72 minus 6, which is equal to 66. So which is equal to 665. So the required value of n is 6. So finally the value of n is equal to 6. Thank you.